Hello, my name is Timothy Nassar. This is my presentation on regenerative braking systems for the electromagnetics course. So the topics covered in this presentation will be the importance of regenerative braking, what it is. Also, we'll be talking about the relevance to electromagnetics. We'll see a diagram of how regenerative braking systems are implemented onto a car. And I will also demonstrate a rudimentary example of a regenerative braking system. So what is regenerative braking and why is it important? Regenerative braking is when a hybrid or electric vehicle will use the kinetic energy which the vehicle has while it's decelerating to recharge the battery. This improves the efficiency of the vehicle drastically, and it's great because since the vehicle already has a motor on it, an electric motor on it, that motor can also be used as the same generator which recharges the battery. So there's very little complexity added to these designs when a regenerative braking system is implemented. So, for the electromagnetic relevance of regenerative braking is an example of a motional EMF. So, as you can see here, when the accelerator is not being pressed, we're looking at the motor in here, by the way. So when the accelerator is not being pressed, or if we're pressing on the brakes, the wheels are actually going to be spinning this loop. And this B field is going to be constant. So while the wheels are spinning, this loop is going to be spinning, and this loop is going to be connected to some load. In this case, it's going to be the battery which it is recharging. And if we wanted to calculate the voltage over here, we would simply write this equation, which is the area of the loop multiplied by the constant B field multiplied by the angular frequency, which is relative to the speed of the vehicle, and we'll multiply that by the sine of any phase at a given time t. And here's a diagram of a regenerative braking system implemented onto a vehicle. So here, when we're accelerating, a clutch will engage, which tells the motor that it is going to be a motor right now. So this motor will spin the wheels forward, which makes the car move forward. However, if we are braking, or if we're not pressing on the accelerator, the automatic clutch will disengage, and that will tell the motor that it's no longer a motor, it's a generator. And this generator is spinning because the wheels are spinning, which means that energy will be funneled through the inverter and used to charge the battery. And here is a very, very rudimentary example which I've prepared. Here, I'm applying 5 volts to the LED and the battery, so you can see the battery is spinning. That's as if we're in the acceleration portion. But at the same time, I can disconnect the power completely. There's no power going in, but I can spin the motor by hand. This is as if we're braking, And this LED can be thought of as a representation of this battery when we're braking, because I'm delivering some voltage VEMF to the battery. So here are some of the sources I used and my video. And this concludes my presentation. Thank you.